Hello, everybody. I just want to show you my new background book. Oh, falling down a little bit. We got calculus, abstract algebra, geometry, and algebra 1. Now we're gonna in a bin of animal books for my kids. All right, let's talk about linear equation word problems. So just wanted to lighten the mood for a second because we're talking about word problems today. All right. I know you're excited about that. But we laid the foundations last week in week 4. This is week 5. All right. So anyway, so linear equation word problems. We're going to look at tables, graphs. I want you to know the acronym GET. This is a little acronym that I created last year. All right. To think about ways to view mathematical data, I guess we could say. Representations, representation. Okay, get. The G stands for graph. Excuse me, my wife is calling me. I was saying, I believe the G stands for graph. We can graph the data and look at it that way. And E stands for equation. We can use that data to make an equation. And the T stands for table. Usually, we look at the table first. We could graph the data easily, and then from there, we could make an equation. An equation is super helpful for making predictions, finding trends, and other things. All right, so let's get started. We are looking for units, so I'm going to read this, but I'm really on the hunt. I'm on the hunt for units, right? Oh, I already found them. Animals and balloons. So the really nice thing about a table is the X is the first column and the Y. So now I know my variables. And one new thing I want to tell you that relates math to science is that X is our independent variable. You should have heard that in science, I believe. And Y is our dependent variable. So we have two things that are varying, but we have another thing you could say from coding class. The independent variable, the X, is also called an input, right? So we're putting a value in for X, and then what is Y called? It's called the output. So we get an output. So you see, that's why it depends. Our output depends on our input. So the dependent variable depends on the independent variable. And the dependent variable is also always going to be solved for. Be like y equals, and then the whole other expression is over here. Everything else, the numbers, the x, and everything else is on the right side. And y, the dependent variable, is the one that's alone on the left side. Okay. All right, let's keep going. Amira sells balloon animals. She uses the same number of balloons for each animal. Slope. For each is a slope word. So draw a box around that and write slope words for each she makes. The table compares the number of balloon animals sold, sorry, here, and the remaining number of balloons on a certain day. So this should say balloons remaining. All right. How many balloons does Amira use for each? There it is again, for each balloon animal. Slope. They are asking us to find the slope. All right, so let's make a list of slope words. for each, for every, per, um, rate. Yeah, okay, rate of change. All right, so how many balloons? So we're going to use our slope formula. We did slope from a table. So I'm going to pick two coordinates. Let's do 15, 200, and 24, 164. And show you my cool way of doing slope. Oh, actually, I used to do it this way, but now I just put them on top of each other. It's even easier to see. So you know that slope is y2 minus y1 over x2 minus x1, right? So y2 minus y1, that's 200 minus 164. What is that? That is 3, that is 36. 36. Oh, subtracting 36. And then 24 minus 15 is 9. I should know that. Plus 9. So 9 balloons, 36. No, 9 animals use 36 balloons. So the slope is the y over the x. It is negative 36 over 9. And 36 divided by 9 is 4, right? I think it's 4. So the slope is negative 4. How many balloons does Amira use for each balloon animal? She uses 4. All right. Moving right along. Sean, man, why is he doing that? Why is he drinking a slushie as fast as he can? Must be a middle school student. Because, you know, when I was in middle school, we had a slushie machine, and there were some kids that did that. They did not feel good afterwards. Drink your slushie at a regular pace, please. The amount of slushie left in the cup in millimeters, found a unit, as a function of time, seconds. Got me 2 units. Okay. But guess what? On the graph, the units are easy to see too, except on this graph, which is all scrunched up. But it won't be when it's on your assignment. This is just a summary page, so got scrunched. So seconds is right there. Seconds is our x unit, our x variable. Millimeters is right there. That's our y variable. And how much slushy was initially in the cup? You know what that word initially is? That is a y-intercept word. All right, initially. Please write that down. Make sure you have a list of all your keywords. Initially, beginning, to start, you know, before. When we start, the amount we have is the y-intercept. So how much slushy was initially in this cup? We can look right there at the y-intercept. The answer is 600. 600 milliliters. All right, so word problems. Now this one, we're gonna have to sketch a graph. And so we're gonna have to label the units. So let's read this. Zane is a dangerous fellow who likes to go rock climbing in active volcanoes. Okay. One time when he was 20 meters below, sounds like negative 20. Below is a negative word. Below the edge of a volcano. Okay, let's just draw this here. Why is he doing this? Zane is right here. Okay. 20 meters right there. Zane is on the volcano. He heard some rumbling. Uh-oh. It's rumbling. So he decided to climb up out of there as quickly as he could. He managed to climb 4 meters each second. Okay. What is this? That's the slope, right? Out of the volcano safely. Sounds like when he got out, that sounds like an x-intercept, right? End of the situation. Graph the relationship between Zane's elevation relative to the edge of the volcano, which started out at -20, and then the time he got out when he was, okay. So, one thing you should know about time is usually your x, okay? Things happen over time, and so we put time on the x-axis in seconds. All right, so Zane is below the edge of the volcano. So below is negative, above is positive, and he is climbing up. Over time, his elevation, that's what is on the y-axis, is increasing. It's getting closer to 0, which is the edge of the volcano, right? When he gets to 0, that's the edge. And his slope is increasing at 4 meters per second. Okay. So, and then right there, he's at the edge of volcano. And then he's out. He's still in, right? Okay, so I think you're choosing this one. And so we'll talk more about slope-intercept form and that. Oh, wow. Let's talk about it. All right, so since we do know our y-intercept right here, and we do know our slope is 4, right? We can actually write the slope-intercept form of this equation. Now, slope-intercept form is y equals mx plus b. This is slope-intercept form. And m is the slope. And b is the y-intercept. So this is a very helpful way to think about a line because it tells you how fast or slow it's increasing or decreasing. We get the slope right there. And the y-intercept, where did it start? And then we could solve for the x-intercept and find out where did it end. You guys did that last week. So all we got to do for a slope-intercept intro, just a little warm up into y equals mx plus b, is get the terms in the right order. So the m is the coefficient of x, and it's the slope, right? So what is the m in this case? It's -4. And that's the slope. And the y-intercept in this case is -3. Done. All right, and the last assignment, linear equation word problems. More word problems. Rachel is a stunt driver and she's escaping from a building that is about to explode. D represents Rachel's remaining distance in meters. Seconds. All right, I bet that's x. Well, t this time. And then meters is a distance, and that's the d. So how long is the distance Rachel has to drive? So how long is the distance that Rachel has to drive? That sounds like the y-intercept, right? The distance remaining, well, if there's 0 time has went by, that would be all the distance is remaining. And so what is that? It's 220. How long is the distance Rachel has to drive? They're asking us for the distance. They're asking us for y. And they're asking us for the total distance she has to drive. which is before she has started driving. She has to drive the total distance. So before she started is the y-intercept. It's 220. All right, I'm sure you're going to have a lot of good problems, red and yellow, because we got a lot of word problems, and we are going to have some fun this week. Bye, guys.